Hello, welcome to this lecture on arrays. So arrays are one of the data structures that we're going to be looking at in this course. So let's look at what an array is. So basically arrays are complex variables that can hold multiple values of the same data type. So as you can see from the examples at the top there, we have two arrays, right? One called first array and the other called second array. So an array, instead of holding one value like what a variable would do, an array holds multiple values. So this array has got values 1, 2, 3, 4, 5, the same with the second one. And you can see the declaration is a bit different from an ordinary variable. Let's say if you had said int first variable, int second variable, those variables would only hold one value, but an array holds many values. So you'll find that when you declare the array, there is an indication of how many elements it can hold. So in this instance, you'll find that this array, first array, holds 5 elements. So you count from 0. So they always counted from 0. So it's 0, 1, 2, 3, 4. So we've got 5 elements that are in this array, and then we've got another 5 elements in this array. But at times you may not declare the arrays like this. You may actually just write the number of elements that array holds inside these two brackets. So when you declare, say, int, then inside the square brackets you write the number of elements, which is 5, and then first array. That way you would have declared the array correctly. So each element in an each value in an array basically is called an element. So each value, if it's an int array like this 1 is a value, this 2 is a value, is an element, this 1 is an element, this 2 is an element. If it's an array that holds strings, so it could be a string array holding names, right? So it could have 5 names: Taku, Tendai, Tafadzwa, and Taku is an element within that array. So you also need to indicate how many names that array holds, either by stating the number within the square brackets or by actually putting the elements within these curly brackets and instantiating the array like that. So how do you refer to an element within an array? You use what is called an index. So an index is basically a unique identifying number that is used to pinpoint its position in the array. And as I said before, with arrays we start counting the number of elements from 0. We don't start from 1. So in this instance, if you want to find the index or the number that identifies with 3 in the first array, we count 0, 1, 2. So 2 is the index for element number 3. Okay, so if we want to also find the index for the number 5 in the second array, we count 0, 1, 2, 3, 4. So number 5 is in the fourth index of this array. So now when you are traversing through this array for whatever computation you do, you use special for loops that help you to go through each value within the array. We'll look at that later. So some of the operations that you can do with arrays, for example, you may need to go through all the elements and print them one by one. Okay, so there you need to come up with an algorithm that traverses or that goes through the whole array and prints each and every one of the elements in that array. So for example, in this array, first array, we would need an algorithm that first says, okay, within this array, first check index 0 and then print the value in index 0. When you have finished that, check, increase the index. Now you're in index 1, then print the value that is in index 1, then increase the index again, you're now in index 2, print the value that is in index 3. So you're continually iterating through this array until you have printed all the values. So there should be also a way to check if you have reached the last element of the array. So either you may know beforehand how many elements are in that array, or you may need to first check the size of the array. So those are the kind of things that you need to look at as you come up with the algorithm for how you are going to traverse through this array. You can also insert an element. How do you insert an element in an array that takes 10 elements but now has only 8 elements? How do you know which which part is empty. So for example, if it's an array that has got that takes 10 elements, but it has 8 elements at the moment, what you do is you first measure the size of the array, that is the number of elements that are already stored in there, and then it will give you the number. So the first, if we are creating an algorithm, we would say, number one, check how many elements are in the array. So we check and we find that our array is of size 10, but we have 8 elements. That means our next element that we are going to insert in there will go into index number 8. Remember, we said we count starting from 0, so the 9th element will be referred to in index number 8. So after you have entered into index number 8, then you have managed to insert a value. Then if you want to enter another value, you also check if the index is less than or equal to the index that is allowed by the size of the array. So that's how you come up with the step-by-step procedures for inserting. The same goes for deleting. You need to find a way of how you delete, and if you delete, what does it mean for the elements? So if you've got 5 elements and then you delete an element on number 3, that means the index for the element that was on number 4 is now shifted to number 3, because there is no more, the previous number 3 has been removed. Then the fourth element takes the second index, and the like. So you need to come up with these algorithms for traversing, insertion, deletion, search, and update. So as you can see from what I've said, the idea is when you're given a scenario where, for example, I said update an element at a given index within an array, you are supposed to now think of the steps that you're going to take to be able to do that before you even start programming it using some special programming language or some code. You should sit down, take a piece of paper, and then start writing down the steps that you would follow if you're going to do that. Then after you now have the steps, you then prove those steps by actually taking a pseudo number of your choice. Then you try to, for example, update that number within at a certain index within the array, and then you then program that algorithm into using a programming language, and then you prove that it works for that given scenario. So at times you may need to actually compare arrays, okay? So if you're going to compare arrays, for example, by just looking at these two arrays, first array and second array look very similar, right? But if we write the code this way, where we say if first array is equal to second array, then we should print that the arrays are the same. Else we should print that the arrays are not the same. But if we compare it this way, what we are actually going to get here is the answer that the arrays are not the same. Why? It's because with this kind of instance, we are not comparing the values of the array, but we are comparing the references. We are comparing the storage references of these arrays. So you find that this one is stored in a different area or different storage block compared to this one. So when you are comparing now, it's trying to say, okay, this one and this one, are they similar in terms of where they are stored in storage? No, they are not. So it will give you the arrays are not the same. So what you need to do now, if you want to compare, let's say you want to compare index by index in an array, you'd say first array index 0 and second array index 0, are they similar? So what you'd need is to first go into the array, then pull out the value at index 0, then compare it to the value of index 0 in the other array. That's how now you actually see whether they contain the values, because now you're comparing values and not indices. So that's something that you should also keep in mind. Then you can, the other algorithms that you may need to come up with is adding up all the elements in an array. So that means you are traversing the array and adding up each element to each element until you have the total. Then you've got the average, the minimum, and the maximum element. These are some of the things that you need to do as you come up with your algorithms. So we have already spoken of a partially filled array. So a partially filled array is an array where it currently has fewer elements than it can store. So if it takes 12 elements and it currently has 6 elements, then it's a partially filled array. Then if you've got a partially filled array, it may waste space because there are going to be some storage blocks that are going to be reserved for your array, but it's not using them. Okay, so for you, as you add more elements into the array, there's need for you to keep track of how many elements have been added and how many elements can still be added, okay, depending on the size of the array. So I think that's what we can say about arrays right now. And you find that arrays are going to be used greatly by the other data structures as we modify the array and how it's computed and how it's manipulated to come up with the rest of the data structures on how they can actually store information for various situations. So you'll see that as we go through this lecture and we implement other data structures. Thank you for watching this video.